So guys, we are going to continue what all things we have learned till now. I'm again going to write down all the formulas so that you don't get confused with respect to anything. So first of all, the indication that we are going to use is that specifically for population. So this will be my population information, right? And probably with some other color, I'm going to define my sample. Okay. Now, with respect to population, usually the population is actually denoted by capital N. Okay. So suppose I go and denote this by capital N, and the population mean, which is actually given by mu, is actually defined by the formula that is summation of I is equal to 1 to capital N x of I divided by capital N, right? So here we are going to do the summation of all the data points that are present in x of I, and that is what we basically say this as population mean. Then we define the population variance, which is sigma square, and here again you have to write it as summation of I is equal to 1 to n x of I minus mu whole square divided by capital N. Okay, so this is basically this population variance formula. And finally, you'll be able to see one more terminology called as standard deviation. Okay, now usually standard deviation is given by, it's nothing but if you want to calculate standard deviation, you just have to find out root of sigma square. Okay, that basically means this is nothing but square root of the population variance will actually help you to calculate the population standard deviation. So this is basically my population standard deviation. Okay, population standard deviation. Now, why population standard deviation will be used, I'll talk about it with much detail in the upcoming section, but just understand that the variance actually gives you the spread, the dispersion, right? Whereas a standard deviation will actually tell you that how far you are away from the mean. So this basically says that suppose I select a data point, okay, it tells that how far a data point is away from the mean. Okay, away from the mean. Suppose if I have a scenario wherein suppose I have something like this, right? And if I have values like 3, 4, 5, 6, okay, 2, 1, 0. Let's consider that I have this particular data. Now, why I have written after 3, 4? Let's consider that my standard deviation is 1, right? If my standard deviation is 1, then I basically say that suppose if I want to find out like 4, how far a data point 4 is away from the mean. Suppose in this particular scenario, my mean is 3. Then I will say that 4 is 1 standard deviation to the right. Okay. Suppose if I say 2 about a data point 2, like how far away it is from the mean, I'll say 2 is 1 standard deviation to the left of the mean. Okay. If I want to talk about 1, if I want to talk about 4.5, 4.5 may be falling somewhere here. Let's consider that. Then this will say that, okay, it is 1.5 standard deviation away from the mean. So this is basically saying that how far a data point is away from the mean. And this unit we basically use at standard deviation. This many standard deviation we are away from the mean. Okay, I will discuss about it more in depth, but let's go and revise this specific formula. And this is my population standard deviation. Over here you can see, and you can also denote this as something like this. You can just say you can also write something like this: sigma is equal to root of population variance. Okay, root of population variance. Now if you use population variance over here as sigma square, you'll be getting that same thing. Okay, so this is perfect. Now similarly with respect to sample data, if I really want to compute the value with respect to sample data, it is quite simple. So again, with respect to sample data, we actually use it as small n. The mean is usually given as x bar. X bar is nothing but you can actually write it as summation of I is equal to small n, and here you can actually specify x of I divided by small n, and this is my mean, sample mean. This is your population mean, and then now you go and compute your sample variance. This is nothing but again summation of I is equal to 1 to small n. Remember the formula, x of I minus x bar whole square divided by, this is important because of Bessel correction, we write it as n minus 1. And finally, if I want to compute this one, S, that is your sample standard deviation, you'll just use this as sample variance, root of sample variance, right? So this is your entire formula. Standard deviation and standard, this specific thing, if I talk about this S is nothing but sample standard deviation. And I've told you what is the use of standard deviation, to basically say that from a data, for a data point, how much far away it is from the mean. Usually in terms of standard deviation, it is basically said. So you can use this entire formula to do different kind of calculations. I'm just revising this, all things we have actually learned. So measure of central tendency, measure of dispersion is done. You really need to remember this: mean, median, mode, standard deviation, sample standard deviation, sample variance. It can, any terminologies can come, and you really need to be able to distinguish it. Okay, so we'll continue our discussion in the next video.